Hello everyone, my name is Reina Hiramatsu. I am a research master student at University of Glasgow. Today I'm going to be talking about origin of the pallasites from the Sericho Meteorite. The main goal of Pallasite studies are to understand the origin of Pallasite meteorites. Because of the composition of the metal and olivines, people concluded that it must form at the core boundaries. However, recent paleomagnetic studies in parasites shows it is impossible to form at the core boundaries. Therefore, people are more looking into the iron volcanism theory for the origins. Here is how iron volcanism might work. When the planet-planet collision happened, the impact was so high that it melted the rocks down to the mantle, as well as further into the planetasmal. It created the FES-rich magmatism so that it could produce the volcanic eruption. I have the newly found pallasite called Sericho for the further investigations. Here is how I did the investigations. I used optical microscope images to understand the brief mineralogy, move on to the scanning electron microscopy to analyze the chemical compositions and orientations of each minerals. All the sample was coming from Natural History Museum in Vienna. Here's the optical microscope images. The reflected light images are good for matrix analysis. There are two types of matrix going on. One is steroid and the other one is metal. On the other hand, transmitted light microscope images are good for silicate. As you can see, you can look into the inside of the olivine crystals very well. By using the VSE images, details of metal structure was showing below. There are Tyenite Island and also Trebisite. The Tyenite Island was for capturing the paleomagnetic signatures. The olivine crystals, actually there were phosphate minerals growing between the olivine crystals. All the mineralogy was calculated by EDS elemental mapping signature. However, the phosphate mineralogy was so complicated that I could not determine either stanfieldite or white granite. All the minerals were surrounded by the iron oxide rims. Orientations of each minerals were recorded by using EBSD. It looks like each individual crystals are not correlated to each other. However, the regional orientation nearby the crystals seem to be correlated to each other. To focus on the olivine crystals, I noticed that the nearby olivine crystals margins are similar to each other, just like a jigsaw puzzle. To focusing on the nearby orientations of the olivine crystals, the movement was just like a cylindrical flow studied by Karato. Based on that, I could see the iron metal was intruding into the telluride and olivine mixtures. Because I thought an iron intrusions, I predicted the two ways of origins. If the iron intrusions was moving upwards, I would imagine it must formed at the magma chamber or magma conduit. On the other hand, if the iron was dropping, just like iron droplet, it must form at the ceiling of magma chamber called pendant. All the chemical reaction was explained on the FEFES phase diagram. Here is the conclusions. Presence of metal and telluride mixture is the evidence of FEFES magmatism. However, the telluride makes up more than 31% of metal matrix in my sample, so that FEFES phase diagram is not really fitting to my sample's case. Olivine crystals orientations reflected to the metal intrusions into the olivine FES mixture, but the scale of iron intrusion may not be large enough to support the iron volcanism theory. Therefore, I would imagine we need more data to support the iron volcanism theory. Thank you for the Natural History Museum in Vienna for letting me use the samples, and thank you for University of Glasgow to collect all the data, as well as Hunterian Museum for the optical microscope. Thank you for listening.